Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. The shaded blue area within the circle shown in the figure is 76.5 pi. If the radius of the circle is 9 and length of AB is equal to length of CD, what is the value of angle ABD? We start this problem by noting that the area of the circle that's given in the figure, given that its radius is 9, the area of the circle will be simply pi r square, and r is 9, the r being the radius. So it's simply pi multiplied by 9 square, and that comes to 81 pi. Now, the circle, the entire circle can be essentially divided up into two areas. So one of those areas is the area that's shaded in blue, that's shown here, right? And the other area is basically that of the smaller sector area, and that I have shaded in green. And these two areas together, they make up the area of the whole circle. And we are given what that blue shaded area is. It's 76.5 pi. So we can find the area of the smaller sector in green by simply subtracting the blue area from the area of the circle. And the area of the circle is 81 pi, that of the blue area is 76.5 pi. So if we subtract the two, we get 4.5 pi, which is the area of this smaller sector in green. The next question to ask is, if we know this sector area, can we find the sector angle? Let's call that angle as theta. And this is actually pretty simple if you know how to do this. For the whole circle, we have an angle of 2 pi around the center, right? 2 pi radians. And for 2 pi radians, the area is 81 pi. So for what value of the sector angle theta in radians will be the sector area equal to 4.5 pi. So we can find the sector angle by simply dividing whatever the sector area is by the area of the circle. So in this case, it's 4.5 pi, the sector area. The area of the circle is 81 pi, and then just multiply it by 2 pi radians. So that will give us the sector angle theta in radians. And if you do the math here, the pi gets cancelled out from numerator and denominator. 4.5 multiplied by 2 gives 9. So it's 9 by 81. And then that comes to 1 by 9. And you are left with a pi in the numerator, right? So you basically get pi by 9. And remember, this is the angle in radians. So if you want to convert into degrees, we know that pi radians is 180 degrees. So we can just use that here. And this is the angle in degrees. So the sector angle theta turns out to be 20 degrees. Now let's look at some of the other information that's given in the problem. So we're given the lengths of these segments AB is equal to CD. Further, since O is the radius of the circle, or rather O is the center of the circle, OA and OC are the radius, right? And they should be equal. So now if we combine the two, if we add these two up, we basically get OA plus AB is equal to OC plus CD, which means OB is equal to OD. So consider the triangle OBD. In this triangle, we have the two sides OB and OD being equal. So that makes triangle OBD an isosceles triangle. And we know that in an isosceles triangle, the angles opposite the equal sides should be equal. So that makes these two angles angle OBD and angle ODB, these are marked in orange, these are equal, and let each of these angles be equal to x. So in triangle OBD, we have the angles as x, and theta, so they should sum up to 180 degrees because sum of angles for triangle should be 180, right? And this comes to 2x plus theta equal to 180 degrees. We know theta is 20 degrees, so theta was a sector angle, right, which turned out to be pi by 9 radians, or when converted to degrees, it's 20 degrees. So 2x plus 20 degrees is 180 degrees, and from this we can pretty easily solve for the value of x, and that turns out to be 80 degrees. So x is basically angle OBD, which is the same as angle ABD, which is what the question asked for. So the correct choice will be option E, 80 degrees.